Hello everyone, I'm Pramuditha and today we are going to discuss about measurement of works in relation to reinforcement bars in concrete elements. At the end of this session you will be able to take measurement and calculate its weight according to BS standards. Therefore we are referring to two main BS standards, which are BS 8666, 2005 and BS 10080. 2005. So this is the task we are going to practicing in this video and I'm going to demonstrate each and every step essential to calculate weight of each steel bar. General details are as follows. Length of the beam is 12 meters and the cross section of the beam is 225 millimeters by 225 millimeters. It consists of two types of high-yield reinforcement bars and they are bar number 1 and 2, which are consecutively 16 mm diameter and 12 mm diameter with different shapes. Also it consists of 6 mm mild steel stirrups at 120 mm centers. Longitudinal section and cross-section are shown here for easy reference. The animation illustrates the layout of bars in both sections. Furthermore, the clear cover for all sides is 20 mm. Bar number 1, 2 and 3 consecutively having U-shape, linear and square shapes. The each lengths of different bar shapes are identified using different but assigned notations and they are P, Q, R, L, M and N irrespective of its shape. Length calculations done by omitting clear cover from dimensions of the concrete element. Calculated length are as follows. P, Q, R, L and M equals 185 millimeters. N and Q equals 11,980 millimeters. A paired schedule is the schedule given in BS 8666, 2005 standard. As per the schedule, length of bar number 1 is calculated by using A plus B plus C R minus 2D formula and the different lengths are as follows. One beam is considered in this example, therefore numbers of members is 1. Type and size of the bar is high yield bar with 16 mm diameter and the shape code is 21. There are two bars of bar number 1 in this concrete element. Identification and allocation of other details are shown in the video. Formula is the key to calculate final length of the bar. No one and illustrated here. Bar number 2 is 12 mm diameter high yield bar bearing a shape code number 0. Way to calculate its total length is shown while illustrating different relationships. Bar number 3 is mild steel reinforcement bar with 6 mm of diameter and bearing a shape code number 51. Calculation of numbers of members, stirrups, in one concrete element is based on simple calculation. Estimation of numbers of spaces is essential prior to calculate numbers of stirrups in one concrete element. After omitting clear cover from the length of concrete element and then divided by spacing is the way to calculate numbers of spaces. Answer for number of spaces is need to rounding up or down to nearest whole number to get number of stirrups. For this example, number of spaces is 99.67 and the numbers of stirrups is 100. Furthermore, calculation steps are shown in the illustration for further references. Prepared bar schedule is as follows. Way forward is calculation of weights according to bar type. 3 different bar types are in this example and calculations are based on BSN 10080, 2005. First step is to calculate weight of the bars is calculation of total length of each bar in concrete element. Multiplication of total numbers of reinforcement members in one concrete element by length of each reinforcement bar will be the answer for cumulative length of one reinforcement bar in concrete element. This demonstration will help you to understand how to calculate total length of one reinforcement bar based on reinforcement schedule. After calculation of cumulative length of each reinforcement bar, the value should be converted into meter. Multiplication of total length and nominal mass per meter length will be the weight of particular reinforcement member. Reinforcement bars having different diameters and because of that mass per unit length is varied. Therefore BSN 10080, 2005 states different weights per unit length according to diameter and the chart is shown here.